All right, so here we go again. A couple more examples, a little more detailed examples, I suppose. We're going to talk about general equations in situations like this, where you've got variables on the left side and the right side, numbers on the left side and the right side. Maybe we've got some parentheses to clear. So let's take a look at what we've got down here and see what we can do. Here's our steps. Step number one is clear parentheses, so you have just terms. Terms are things that are separated by addition and subtraction. This is a term, that's a term, that's a term, that's a term. Combine like terms on left side and right side, and then do the middle school dance. Use the multiplication or division property of equality to kind of solve for 1x equals some number, and our goal is always going to be x equals some number. So that's what we're going to do is solve. So we clear parentheses here. Here's like terms. Here's examples, and now here's some little more detailed examples. All right, I'm going to go right up here. There we go, blue. All right, 7 plus 3 equals 2 times p minus 3. All these should say solve. And by solve, I mean tell me what the variable is, x, and oh, by the way, 1x equals some number. In this case, it'd be a p variable, here's a y variable, here's an x variable, here's a z variable. But essentially, solve means tell me what the variable is equal to, and 1 times the variable is equal to. All right, so step number 1, clear parentheses. 7 plus 3 equals, clear the parentheses here, I got a 2p minus 6. Pay attention to signs. Positive times positive, positive. 2 times 1 is 2, times 1 times p is p. Here this term is positive times negative is negative. 2 times 3 is 6. I'm set. So now I combine like terms and I play the middle school dance. Combine like terms on the left, I guess. 10 equals 2p minus 6. I've combined like terms. No like terms with the variable terms. So now I play the middle school dance. Variables to one side, numbers to the other. Do the opposite of whatever that is in that plus 6. Keep things in columns. Got a minus 6 in our original equation. Add 6 to get to 0. Now see what's changed. 10 plus 6, 16 equals 2p. And I don't want to know what 2p is. I want to know just what the variable p is. So I divide by 2. Divide by 2. My variable p equals 16 divided by 2, 8. Positive divided by positive, positive. Double check. P minus 3, 8 minus 3 is 5 over here in the parentheses. 2 times 5 is 10 on the right side. On the left side, 10. Looks pretty good. All right. Next one. No parentheses to clear out. On the left side, no like terms to combine. On the right side, no like terms to combine. So we're to the middle school dance. What do we have to do? Variables to one side, numbers to the other. I'm going to say that I'm going to move my minus 2.2y from the left side to the right side. And I can do that because there are like terms. I'm going to move those variables to the right side. This becomes 0. Keep things in columns. Helps you keep track of things. Minus 8.3 equals 6.2 minus 2.2 is 4.0, or just 4. Y plus 12.1. Got to move the variables now. So we moved the variables to the right. We got to move the variables to the left. So we've got plus 12.1 in our original equation. We got to subtract 12.1 to get a 0 in this equation. Got to keep things equal left and right. Keep kids happy at Christmas time because this side is equal to that side. You want to make sure that each kid gets the same amount of presents. Negative 8.3 minus 12.1 minus 20.4 equals 4y. I don't want to know what 4y is, and here's where we divide by the coefficient to get on the right side 1y, or just y, equals on the left side negative divided by positive, negative 20.4 divided by 4, 5.1. And there's my answer. I'm not going to double check that because it takes too much. All right, let's go down here. Another example. Wow, here's a bunch of stuff. A bunch of stuff. All right, well, let's see. Clear parentheses. I'm going to clear parentheses and combine like terms at the same time. Here's my like terms over here. 2 and negative 5, I got 7x. Plus 2 minus 5 gives me negative 3, or minus 3 equals. Distribute before you combine like terms, because this is one big term, but we need to combine terms here. We can combine terms over here because they're not inside of parentheses, but we cannot combine that x with that 2x because the parentheses is in the way. Distribute first. 6x. Pay attention to signs and numbers and variables. Positive times positive, positive. 6 times 1, 6. 1 times x, x. Positive times positive, 6 times 3, 18. Plus 2x. Now combine like terms on the right side. 7x minus 3 equals 6x plus 2x, 8x, plus 18. Now do the middle school dance. Variables to one side, numbers to the other. Subtract 7x on the left, subtract 7x on the right. I got minus 3 on the left, 7x has gone away. 8x minus 7x are like terms because they have the same variable, same power. 8 minus 7 is 1x, or just x, plus 18. Subtract 18 because we're still in the middle of the middle school dance. I got negative 3 minus 18, negative 21 equals x. And I think I'm done. Plug negative 21 up in here, you'll get some number up here. Negative 21 would be negative 147, negative 152, negative 149. I'm going off the cuff here. Negative 18 plus 3, negative 15 times 6, negative 90. Let's see, minus 2 times 18, 36, minus 126. Oops, something went wrong there. I did that in my head. Take it from me. Negative 21 should work. Okay, well here's where I took a wrong turn. I think that should be minus 150. Negative 150. This should be negative 21, negative 18, negative 108. And this should be minus 42. And this adds up on the right side at negative 150. On the left side, negative 150 also. All right. Wow, this down here. Let's see. Let's take a look at this one because it's really kind of interesting. Let's see. Clear parentheses. Here I've got a minus parentheses, but I have to assume that there's a minus 1 there. So my 9 stays the same. Negative 1 distributed across this here is negative 1 times z is negative z. Negative 1 times negative 3 is negative times negative positive 3. Plus 4z equals 4z. Negative 5 times positive z minus 5z. Pay attention to the z's and the 2's, because those are some things that could be confusing, and the 5's and s's can be confusing as well. Negative times positive, negative 5 times 2, 10, minus 6. Let's combine like terms. I have 9 plus 3, 12. I have negative z plus 4z plus 3z equals, on the right side, 4z minus 5z is minus z. Minus 10 minus 6, minus 16. All right, let's solve. We've distributed across parentheses. We cleared parentheses. We combined like terms from here to here. Next step is doing the middle school dance, step 3 and 4 in our examples. Move the variables to one side and numbers to the other. I'm going to add z on the right, add z on the left. 12 plus 4z equals negative 16. I'm going to subtract 12 and subtract 12. I'm going to extend my page here. 4z equals negative 16 minus 12 minus 28. Divide by 4 to get my variable just by itself. 1z equals negative divided by positive, negative 28 divided by 4, 7. And there's my answer. Z equals 7. We've got a couple answers. So in the blue, top left and top right green, and bottom left red and bottom right black, we have equations that gave us answers. P equals Y equals X equals Z equals. But at some time, there might be situations where we get to where we don't have an answer. If we start working on an equation, and after working on that equation, we have some odd situation, something like 4 equals 5, or 0 equals 10, or 0 equals 15, or something that doesn't make sense, then it's called a contradiction and there's no solution. Because when is 4 equal to 5? Never. When is 0 equal to 10? Never. When is 0 equal to 15? Never. These things don't happen, so therefore there's no solution. There's other situations as well where we say we start working on an equation, and after working on an equation we get to something like 4 equals 4. If we get to 4 equals 4, or 0 equals 0, or x equals x, or some number 15 equals 15, something like that, all these mean that our solution means that our solution is any number. Any number could go in there. If we find a solution, or if we get to an equation that gives us these, something like this, x equals x, 15 equals 15. When does that happen? Always. We can put any number, so any number is our solution. So any number, or any number, really any number in the real numbers is our solution.